Hey guys, hope everybody's doing well. This week's topic is bonding, so I thought I'd make a little video, I know pretty fancy, to help explain bonding. To get, I guess, the whole idea down, we're going to start with reviewing what you guys did last week, because some of that's going to be important for this week. Last week was the first time that we kind of looked at the periodic table, and I would ask you questions about like numbers of protons, neutrons, things like that. And so if you understood everything last week, basically to figure out the number of protons that an atom has, all you have to do is find that type of atom on the periodic table. So if we're talking about iron, iron is number 26 on the periodic table, so iron has 26 protons in the nucleus, and it was that easy. So if you were looking at calcium, calcium's number 20, that means it has 20 protons. So already you guys know how the periodic table is configured. It's laid out based on number of protons. So as you get farther and farther down, these elements have more and more mass because they have more protons, which means they're going to have more neutrons, and electrons is going to be the focus of today's topic. So I guess the new material kind of starts in the fact that if an element has one proton, then it naturally also has one electron. So the way this week that we're going to figure out how many electrons something has is to still just look and see what number it is on the periodic table. So magnesium is number 12 on the periodic table, which means it has 12 protons. And now what we're adding to that is we now know that it has 12 electrons as well. So nice and easy, you're just looking up the number on the periodic table and you'll get electrons. Last week, over here and draw you guys some pretty pictures. Last week we kind of also started to talk about the position of some of these particles. We called them subatomic particles just because they're smaller than an atom, but they're the parts that make up an atom. And so what we did was we talked about the particles that are inside the nucleus and ones that are outside the nucleus. So if this is the nucleus of an atom, which is kind of the center part. You guys have heard the term nucleus before for sure, like when you talked about cells and things like that. The protons, let's see if I can fit this in there, protons and neutrons are in here. So they're condensed in that small area in the middle, and then we labeled all of the electrons as being located outside the nucleus or in something that's called the cloud. And so however we want to draw that, somewhere out here in this range are these electrons. The electrons kind of orbit around the center. So if you think of them as kind of like little mini planets orbiting around the center of this atom, which is the nucleus, that's not a bad way to model the atom. But they're not just randomly filling in spaces out here. They actually have like assigned parking spaces or assigned spots where we can predict that they will be. And so that's going to be kind of the focus of this week, is starting to talk about these electrons, because the place where the electrons are at dictates a lot about what the atom itself is going to do, and especially when it comes to bonding with other elements on the periodic table to make more complicated things. So I guess to kind of jump right in, basically you have your protons and your neutrons in the center, and then you have this cloud. In the cloud, there's different layers. There are different places where these electrons can be at. And so if we put, let's see, I'll just draw kind of a dot here to represent the nucleus. And then I'm going to draw what they call shells, like electron cloud shells. So here's the first one. Here's the second one. And here is the third one. That didn't go so well, but close enough. So anyway, nucleus here, and then three shells. We have the innermost shell. Switch colors here, maybe that'll show up. So here's the innermost shell. So that's represented by this circle. This inner shell is small. It can only hold up to 2 electrons. So 2 electrons is its maximum. So this could have up to 2 electrons. I'll go ahead and just draw them in. Electrons are just little dots that we put on here. So that can hold a maximum of 2 electrons. The next shell out, so this one, the second shell, can hold up to 8 electrons. So it actually is bigger, and now it can kind of house, let's see if I can get 8 dots drawn on here, 4, 5, 6, 7, 8. It can actually hold up to 8 electrons, and the third shell can do the exact same thing. It can hold 8 electrons also. So I'm just going to draw these dots in here. 1, 2, 3, 4, 5, 6, 7, 8. So right there, we kind of get the feel for what this cloud is going to be like. The innermost layer, which is here, can hold up to 2 electrons. And then each layer after that can hold up to 8. So basically what do we have here? We've got 18 electrons drawn on this little diagram, with the nucleus being kind of right in the middle. And so getting an idea about this is going to allow us to understand these things that we're going to call charges today when we talk about ionic bonding, and understand where those charges come from. So let's just draw a couple of these out for some specific elements. So I'm going to put the periodic table back under here, and let's just start with one like lithium. So here's lithium. We look at lithium, we know it's got 3 protons, which also means 3 electrons. And so if we're going to draw what lithium actually looks like using one of these diagrams, then we know we have to have 3 electrons on there. And so if we come back here to our piece of paper and we draw this out, I'm going to put Li in the middle now, just to represent that we're talking about lithium atoms. And then I'm going to draw the shells. So I'm going to draw the first shell here. Now we know lithium has 3 electrons. The innermost shell here can only hold 2, so that's what it's going to do. It's going to fill these up first. And so we're going to put 2 electrons in there. I drew them away from each other because they're both negatively charged, which means they're going to repel, so they're not going to park themselves right next to each other. There's the innermost shell. It's full. It's got 2 electrons now. But we know that lithium has 3 electrons, and we don't have 3 drawn, which means we have to draw another shell. And this outer shell here, it can hold up to 8, but lithium only has 3 electrons, and we've already drawn 2. So all we have to do here, and you can kind of choose where you want to draw it. All we have to do here is put 1 more electron. Now we've drawn lithium with its 3 electrons, and they're all parked in the correct location. So that's kind of a skill that helps you visualize some of the stuff we're going to talk about. Ultimately, when these things go to combine, combining is what we're going to call bonding. So bonding. This is when atoms combine with other atoms. So in other words, we're going to make molecules out of just these atoms. The position of these electrons is what's going to dictate how they bond. And so if we look at lithium, we've got what we'll call a full inner shell, because it's got 2 electrons, and that's the most that it could possibly have there. And then this outermost shell only has 1. So this definitely isn't full because it has all these other parking spots here. So the name of the game here when it comes to ionic bonding, so I'm going to put that, if I can spell it right, ionic bonding, is that it's looking to transfer electrons to get a full outer shell. So it wants to have a full outer shell. This is all in the PowerPoint. You guys should have read through that already. Outer shell. So ionic bonding, full outer shell is what we're looking for here. If you notice, it definitely doesn't have a full outer shell. It's only got 1. What it's going to look to do is it's going to look to transfer. It's going to look to give this electron away. And if it's able to give this electron away, then look at what happens. We basically take away this outer shell because it no longer is needed, and we end up with a full inner shell. And so it's going to look to get rid of this 1 electron right here. And so what we're going to say that lithium has is a charge of +1. And what that +1 actually means is that it's looking to give away this electron. It has 1 extra electron that it wants to get rid of. So that's going to be a +1 charge. We're going to label these on the periodic table here in a few minutes, but just to get us thinking about all the things. Let's try another one. Here's periodic table again. Let's give, fluorine. Let's give fluorine a try. Number 9 on the periodic table, which means 9 protons, which means 9 electrons. So let's draw the cloud diagram for fluorine. So we'll come right back out here. Switch to purple, draw an F for fluorine. First shell, remember we have 9 electrons now, so this one's going to have some more dots. First shell can hold a maximum of 2 electrons, so I'm going to go ahead and fill those in. We need another shell. Second shell. Remember, we need 9 total electrons. We've already done 2 here, so that means I need 7 electrons. And hopefully I counted those right. So now we have fluorine, atom of fluorine, with all of its electrons represented on this diagram. And if you remember, what fluorine wants is to have a full outer shell. Okay, well, here's its outer shell, right? And if we look to see how many it has 7 electrons in its outer shell. A full outer shell here is 8, right? And so if it could get one more right here, then it would have a full outer shell. The way we describe this is we would say that fluorine has a -1 charge because it's missing 1 electron out of this outer shell. It's missing 1 right here. So that's why we call it -1. And so it's looking to acquire. It wants to gain an electron because if it could park 1 right here, then what we end up with would be a full outer shell and fluorine is completely happy. So if you kind of look at these two things, you've got this atom here, lithium, that's looking to give 1 electron away. And then you've got fluorine down here that wants 1 electron. So this is like the perfect match. Like this one wants to give 1 away, this one needs 1. So these two things are going to combine. These two things are going to bond. And because they're oppositely charged, these are going to form an ionic bond. And so we're going to make a totally different substance now when these atoms combine. And the new substance will be LiF. And so we use the symbols for these and we write them together to form the new compound. There's no spaces or gaps. We use upper and lower case, so be careful with that, exactly as they appear on the periodic table. But this would be the new compound that gets formed. And this would mean we've got 1 lithium combining with 1 fluorine. This transferred or gave away an electron here, so that fluorine now has a full outer shell and lithium now has a full outer shell because it's just left with these 2 on this innermost ring. So perfectly done. We formed our new compound. Here is an ionic bond. So that's kind of the way these work. I think we'll go through at least one more of these, and then you guys can practice some of the ones in the PowerPoint and see if these make some sense. But yeah, let's go ahead and just draw out a couple and combine them. All right, let's make something up here. Let's do something slightly more complicated. How about let's take, we won't get too crazy. Let's do sodium. So sodium has 11 electrons. So I'm going to draw that. Sodium, 11 electrons. So 2. Terrible circle, but we'll do it. All right, 3, 4, 5, 6, 7, 10. So there's sodium's 11 electrons. If you notice again in its outermost shell, which is the 3rd shell this time, there's 1. There's just 1. And so this one is going to have a +1 charge as well. It's looking to get rid of that electron. And let's combine it with about oxygen here. So oxygen, 8 electrons. So I'll put the O for oxygen. And then first shell has 2. Second shell has 6. 1, 2, 3, 4, 5, 6. I'm going to leave this gap over here so you guys can see the missing electrons. So now if you look at this in its outermost shell, this thing can hold 8. It has 6 electrons there. So that means it's missing 2, right? And so we're going to call this a -2 charge because it's looking to get 2 electrons here to fill in these gaps. So -2 charge on that. So if these are going to form an ionic bond, and they can, they're oppositely charged, they can come together. But what we have to do is we have to basically get these charges to balance out. And so if you look up here, each atom of sodium has a +1 charge. Each atom of oxygen has a -2 charge. So we can't just put them together like we did here and get them to balance, because here we had a +1 and a -1 and we just had one of each and things balanced out perfectly. Here it's a little bit more complicated, not too much, but slightly more complicated, because a +1 is not going to cancel out a -2. So in other words, we can't just send this one electron down here and get this thing to be happy, because then oxygen still doesn't have a full outer shell. So really what we're going to need is we're going to need 2 sodiums to transfer electrons. And if we have 2 sodiums, that means we would get 2 electrons transferred down here to oxygen. And then we would have full outer shells for our sodium atoms and for our oxygen atom. And so the way this gets expressed is we need 2 of these. We need 2 +1s to cancel out a -2. And so the way this gets written is we have Na2O. So what that means, that little subscript 2 there, that means we have 2 sodiums and 1 oxygen. And then you can double check yourselves to make sure that your numbers are right. Look at sodium and say, okay, I've got 2 of these. So if I have 2 of these, then right here, I've got a +2 charge. And then I've got just 1 oxygen, and each oxygen is -2. And if these will cancel, and they will, then you've done it right and life is good. So that's a little bit more of a complicated version, but you'll have some of those for sure to kind of look at and to combine. So let's go ahead and label periodic table. That's kind of the last step. This will kind of be easy compared to what you just did. I kind of showed you all of the details, and now we're just going to label these out to make these easier to get. This whole first column, one of the kind of learning some of the relationships here on the periodic table. They're in order based on number of protons, so we've got that already. The columns and rows also mean something, and so what we're going to do is we're going to look at basically 5 columns. First one being this column right here, so starting with hydrogen and going all the way down here. This whole column has the exact same charge. So when you draw out these diagrams like we've been doing, what you'll see is these are all going to end up with 1 electron in its outermost shell. And so what we called that was +1. These all have an extra electron that they're going to look to get rid of. If we hop over here, this column here, this column, when you draw these diagrams out like we did, I think we did magnesium, what you'll see is they're going to have 2 extras in their outermost shell. So this column, all of those atoms have a +2 charge. From there, we're going to switch over to the other side of the periodic table. You guys may have talked maybe last year or a couple years ago about these things called noble gases. This column here, all the way on the right, these are all noble gases, and what makes them special is that they already have a full outer shell. So like if you draw out helium's diagram, you're going to see in its outer shell, its first shell, it has 2 and it's full. If you draw out neon, you'll have 2 in its inner shell and then 8 in its outer shell, so full outer shell. So these noble gases will not combine with other elements because they already have a full outer shell, and so they're not looking to combine, get rid of, acquire, anything like that. So because of that, we give them a charge of 0. They have no charge based on those electrons. If we hop over here, starting with fluorine, and you go all the way down this column, when you draw these out, which we did fluorine, when you draw these out, what you'll see is they're missing 1 electron in their outer shell. And so since they're missing 1, that's what we called a negative charge. Missing 1 electron, -1. And then this next column over, we did oxygen. You'll find that all of these are missing 2 electrons in their outer shell, and so we will call that -2. So those are basically the 5 columns, if I can get them all to squeeze on here, the 5 columns that we're concerned with. And what I'm going to ask you to do is put some of these things together. So to form compounds using ionic bonds, and ionic bonds use 1 positively charged atom. Well, I guess I shouldn't say 1. 1 type of positively charged atoms and one type of negatively charged. So you'll have one type of element coming from this side combining with one type of element from this side. You just have to balance the charges, so be careful with that, as I kind of showed you with some of the examples. But I think that's about it. These are, it takes a little while to get onto these, so feel free to email me. Watch this video. I've put some examples in the PowerPoint, so check those out. I've also included the answers, so definitely run through those. Use your periodic table to help you out. This will help out a lot as well. If you label these columns, you don't have to go through and draw all those diagrams unless you want to. But I just wanted to show you those diagrams so that you knew where these charges came from and we weren't just making stuff up here. So anyway, good luck, miss you guys, and let me know how I can help. See ya.